Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And, this week we're going to kind of, play a twofer and, kind of talk about, robots and drones, oh my, at this point. It's really, when you kind of debate on, what is a robot? Is it a six DOF robot arm? Is it something that's, a movable piece of machinery? Or, is it a humanoid looking, robot that walks and talks and, kind of stares back at you? We've all seen the movies, so, go from there. So, but then you talk about what is a drone? Is a drone a automated guided vehicle? Is it a helicopter drone? Is it a delivery drone, airplane, whatnot? Is it a surveillance? Is it for moving people? Hell, frickin', I think it is Walmart or Amazon. I think it's Walmart. That's trying to do drone delivery. It's one of those things. But
yeah,
it's just when we start talking about robots and drones, it's a very interesting world that we dive into. But when y'all hear that, starting from what is the basics, moving towards more of our advanced, and open source worlds, what are y'all thinking?
Well, I think if you're talking robots, I guess the classic, I would say a classic definition would be you assemble some electronics, motors, some electronics to control the motors, and then you would write some code, and then with that code, the robot would go out, whether you're using some type of sensor for avoidance or detecting objects so it could move around. So something simple is like, say, a robotic vacuum cleaner or a robotic lawnmower. And a drone would be a little bit different. A drone, although it would have some of those properties and characteristics, a drone is also probably going to have more of a tethered relationship with the human. So, yeah, you would have some code, I would say more like firmware, that would be basis, but the human is probably doing most of the avoidance or navigation.
Now, you brought up the robot vacuum cleaner. Mm-hmm. How can they avoid everything in your house? Everything in your house. Until you have a puppy that really wants to relieve itself on the carpet. Then decides it's going to drag it through the house.
Mm-hmm. Yeah. Mm-hmm. I mean, if it's anything like me, my cats just kind of stand in the way and they just hit it, and it's like, no, I'm not moving. You have to go around.
Yeah. There's always little spots where cats are standing.
No, I mean, you raise a good point though, Ed. I that's exactly the way I was thinking. Is like, hey, well, to me, when is it a robot becomes a drone at a certain point, or a drone becomes a robot at a certain point, or what defines either? I think the user, or the input from the user rather, or data from something user controlled is guiding that. So I mean, for instance, the Walmart, somebody's buying something, so then I'm hoping that Walmart has some type of pilot that drives that drone to your house or something like that. That's the same. It's very similar to what we're getting to with Uber and Uber Eats and DoorDash and things like that. Yeah. To me, I wouldn't be surprised in the next 10 years if that, with the emergence of the automated driving and the ordering food like that, they combine them and they're going through the drive-through. People are making the food, putting it in the car goes to your house.
Yeah, it's like if you start talking about it, when I start thinking about robots, you're really talking about, If you're talking about, your standard, 4'd-off, 6'd-off robot arms, you're talking about the Cuckoos, the ABBs, that stuff that's out there right now. You're talking about, the design of a robot arm that has been the same for decades, right? And then you start moving more into the humanoid robots and stuff like that when you start dealing with everything else.
Boston Dynamics.
Right, the Boston Dynamics thing, the SpaceX thing that they're coming out with, or Tesla. But then you start getting into your drones. You talk about automated ground vehicles or guided vehicles. You talk about the iRobot. Mm-hmm. That is a AGV, an interior AGV. You have stuff that you're dealing with. Like SafeLog, for instance. They make their version of the AGVs. But also, then you have the wonderful world of, you start getting like the delivery stuff that we were talking about. Like if you're talking about like how Walmart does it with an aerial drone. They plug a GPS into the darn thing and send it.
Yeah.
Rip it and send it. And hook the package up too and let it go.
I'd hope somebody was watching though.
They probably have a camera on board, but the thing is no one's controlling it. It's flying by itself.
So it's untethered.
It's untethered. It's often it's like, if you think about it, we have military drones that are hundreds of thousands of miles away from each individual pilot. And all they are sitting back watching. The airplane, the plane itself is flying an autonomous route. That it knows which way to go. And most of your drones you can get from like Best Buy or whatever can do the same thing if you program right or write a process in Python.
Right.
And then you start getting that mixture of AGV and robot when you start jumping into the KUKA AGV line, where the KUKA AGV line is this AGV that runs on four pneumatics tires, and it's got a 6 DOF robot arm on the back of it that picks buckets off of counters and puts them down, puts them back up. Or what we've seen in the past, they use those to pull the print beds out of center printers.
Yep.
And move on to keep your printer system moving. Mm-hmm. It's just many different ways of getting it working of how you really want it to.
Yeah, the printer's my preferred way though.
Yeah. I think the key, like I said, when we're talking about so somebody I say monitoring, well, that can be done almost the same way we use SIEMs to monitor networks.
Yeah.
So basically, with the evolution of AI, machine learning, and deep learning and data analytics, those type of things can be taught over time. And then, like you said, we have GPS. And then, say, for example, if GPS somehow fails, you also have terrain. So you have cameras on board that can look at terrains and, okay, this is where I'm supposed to be. Hey, I'm north, west, south, east. So I think those are things that will probably put in, but it's a valid point that, yes, it's possible, but is it mature enough to, with the landscape of the day, with like the threat actors and nation states that are, compromising infrastructure in countries, you better have a robust network.
Yeah.
Yeah. You mean, what was it, a couple months ago, there was a software company's auto driver bricked a whole bunch of cars, and they all went to one street, and they just stopped. So, like, you're not careful. Yeah. That car's going in your house. So.
Well, nothing's perfect.
Yeah, that's true. That's true.
Everything's capable of of everything else.
Yeah, that's true.
And I think that's kind of where you kind of see the next innovation coming and stuff like that. You got these secure protocols that they're using and stuff like that. Stuff that it's like even if we knew, we couldn't disclose. But that where they're self-protecting. At that point, it's like you start dealing like what you're talking about with terrain mapping. You start dealing in the homing, and you're homing back using old school homing technology to home back to a target, that your point of origin.
Well, if you're gonna you can always use RF or microwave, and then use land of sight, like the same way we do with phones.
Yeah,
you could set up some type of microwave tower, and that microwave tower could be your CNC, a good CNC, a good command and control center.
Your relay and repeat center.
Yeah, so then that would do. But like I said, the reason I bring up the security side of it, the reason it's so hard is because you cannot. For example, there are techniques now that even in an air gap system, that you can do things where you can actually figure out keystrokes that are being pushed on keyboards. There's even the electronic signals that are being dispersed from the PCs or so they can I mean, it's crazy. Like some of the stuff that they can do now, it's wild. Like I think it was a university. I forget which one, but they did an experiment where they was able to have a device like a phone next to the PC, and the phone picked up all of the keystrokes, and the phone sent the keystrokes, everything the person was typing in. Like when they typed in the password, it sent it to the CNC.
All right. Keep your phones away from my keyboard. Got it. Yeah, no thanks.
Yeah.
I mean, I'm saying like that's extreme. You're talking nation states.
That's pretty impressive, though.
Yeah, but those type of things are there because everything has a frequency. Yeah. So even the power supply, they were even able to monitor the power supply and get information from the power supply because it's a frequency. It's a switch mode power supply. Yeah. So it runs at a frequency. So they were even able to gather information from that.
That's pretty incredible. I think that goes into what we were talking about the other day was SDR or something like that.
Think about it, that's how sonar worked for the longest time. Sonar worked from listening in on other combatant commands, submarines, ships, or whatever, and listening to the screws, on the back of the submarines to determine how fast that screw was turning, depending on how fast it was going, and also depending on which direction it was heading, because it was using DF or direction finding, stuff, back in the day. Now it's probably a little different, but that's just how it goes.
If I know how fast you're going and which direction you're going,
I can hit you.
I can use some mathematics.
Yeah,
and at least get within
exactly.
Punching into a targeting system, it'll determine how. And if it knows which direction you're heading, I could put a point on a map, and I can now figure out how long it's going to take you to get to said point A, point A or point B, and actually direction find you. All I got to do is intercept you at that point, as long as I know where you're at. Yeah. And now if you've ever seen down periscope, you'd understand how that works. Yeah.
I have not.
Time for Red October?
Yeah, I've seen that.
Oh, okay.
Down periscope, no.
Yeah, he hasn't seen the comedy version of Hunt for Red October.
Okay.
Right? And it's just, next thing you know, everybody's going to be screaming Wolverines. But it's just, right now you start dealing with, the greatest of the great, going, further into this, further into robots and drones and stuff like that. That, KUKA, for example, and ABB for that matter, two of the biggest suppliers we got of robots right now. We're putting forth so much technology in these things, to support manufacturing objectives, to support small business, for the pick and place robots. And, some of the painting robots, some of the paint booth, some of the small auto shop paint companies are buying these older ABB robots and putting them in their shops to help ease the load, because we're dealing in a time of where we have an issue hiring people. So what's the best? If you can't hire somebody, you replace them with a robot. It's going to cost you the same amount to hire a robot programmer to come out and program the darn thing, that it will for a couple months worth of salary of the human, and then you don't have to worry about it again. You make sure it's lubricated, make sure it's got power, make sure it's got air, and make sure it's got good cooling water for welding with it. Yeah. And well, there you go.
The main thing with robotics is its repeatability, and it's doing, I would say, menial jobs.
Yeah. Consistency.
So like for example, with the paint robot, so that robot can repeat at a certain speed, millimeters per second, over and over, and never skip a beat. Now you have to deal with things like the parameters that deal with the speed of the bell that's, atomizing the paint. Then you have to deal with like the shape air that's making the cone of the paint a certain, wider or thinner. And then you have to deal with like, okay, I have to have high voltage on here, but maybe I don't have high voltage on there. So those are some of the things you have to look at, with the robot. But once you do that program, it can repeat that. Whereas a human, it can set that equipment, but at some point, some fatigue's going to come in, and then you'll get some defects.
And it's like, if you think about it, like AGVs, for example, you start talking about drones, or automated ground vehicles. They repeat the same process over and over again, or they follow a pattern. They follow an electrical signal that's embedded in the concrete that points them from point A to point B. You repeat the same process all day long. No human wants to push a cart back and forth all day long. Just not how it goes.
What's the price point? No, it's kidding.
Well, do anything for Snickers bar. Right?
Yeah, right.
Klondike bar.
That's what it is.
You want to take, like, when you say we're replacing a human, the goal for anybody. So when we're talking the digital revolution, that's coming.
Yeah, it's not to replace the human.
It's not to replace people. It's to take that person and use that person as an expert for knowing what is supposed to be done in that process.
Yep.
So you're getting a process expert. So, like, say, for example, and
make the human better.
Yeah, and make the company more profitable.
Right.
Because you give the human something that
makes
meaning, and it's a challenge to them, and it's not the same thing over and over. You're gonna get a different product from that person.
And it's a trade. If you're learning, robot programming and maintenance, even from the smallest standpoint, same thing with drones. It's like the 3D printers. You learn a trade.
Yep.
You got that trade down pat. You got something you can write home about and say, hey, guess what? I know how to program a robot. Yeah. And they can throw that on your resume, maybe go do a couple classes, and guess what? Get certified in this stuff. And the thing is, it's not like when I say replace a human, it's more, let's say, in a joking manner, because I don't believe in fully replacing a human. That's like, I believe what Ed does. We want to make the best human possible, and what that is do pretty much human machine interfaces. Where the human and the machine are working together. Having the interactions happen. Having that human take care of that robot, for its things. Load it, feed it. Let the robot do the work that, is backbreaking for the human, and that's going to wear that human out. But make sure they understand how to take care of that robot, if something was to happen. Make them learn how to do the teach pin. Make them learn how to freaking program it to get it to a point. Because then you got somebody who's now proud of what they do, proud of the station they work in, that they know every little bit about that particular robot. They know it. Oh man, that thing, they can tell maintenance flat out. Well, it's on the fritz because it did this, it didn't report the keystrokes, it didn't like what I was putting in the panel, it didn't like this, so now we might have to replace it. They know that robot down to the pat, which takes our advanced analytics stuff we've talked about before, takes our machine learning stuff we've done before, and gets us to a point where we can replace that robot faster, quicker, and on time to prevent line stoppage.
Yeah, minimal downtime.
Exactly.
And then I like to set up a question for Champ. So here's the scenario. So, more and more people are discovering 3D printing and some of the advantages of having a 3D printer and learning how to use this technology. How do you think that would affect, say, a STEM student that was wanting to learn about robotics? What do you think the benefit of having a 3D printer would do?
Oh, I mean, that's a great question, because honestly, I think that, a mechatronics student, a engineering student, or let's just say get down to someone who's visual learner, it'd be groundbreaking for them, because you could still be, a smart student, a STEM student, but you need to visually draw it on the board, or I can't do my math this way, I gotta stack apples and figure it out that way. So to me, I think it would change the game. It would not only speed up those that are visual learners, it would, honestly, I don't know how many times I've been caught just staring at my printer. It's mesmerizing. So it's something that's soothing, and I think that not only that, is it builds on, 3D printing can be the spectacle, but it builds on the, I guess, creativity or the problem solving mind, because then you're like, oh man, my imagination's really my limit. So if I want to make something, let's say to be a robot arm to remove this and keep it automated, I can do that, and that it's an idea creator. Right? And I think that if it's also the way that you can make some of those ideas a reality and have a physical form for those things, it's also rewarding. So not only will you, stimulate that kid's life in showing them something that, 3D printers right now are not in every home. Like, unless you have a 3D printer, you're probably going to, watch it. It's going to be interesting, at least. If you've never seen it, you're going to watch it for, 5-10 minutes. So if you're in a STEM environment and you're learning on things like that, that's probably much more than 5 minutes. You're probably gonna hook a kid for life on manufacturing and some of that thing. So I think it would make more sense just to have it in all those platforms.
You saying 3AAS would be a thing? 3D printing as a service.
Yeah. No, seriously. You come in. You could do a lesson plan. Kind of like how did you guys have? The book fair used to come in and there would be. Something like that. There would be a traveling library that we have in our hometown. Yeah. So something like that, where it's like, hey, you guys
traveling STEM.
Yeah, traveling STEM. You guys have reached out to us. We have a lesson plan. You want to learn about this? We're gonna do 3D printing, and while these are printing, we're gonna show you the prints we've already prepped, so that you can see how it works. Like that right there. That's a field trip for.
You don't have to go anywhere.
Yeah, you don't have to go anywhere. That's a whole kid's day. And if you tell them, hey, we're not going to do any schoolwork. We're just going to go make some things and then have fun with those things.
So I'm going to set up the next question for Nick. So we talked about robotics. We talked about autonomous vehicles. We talked about drones. We've talked about cars that drive themselves. And we talked about making a better human. Mm-hmm. So do you think 3D printing, we're 3D printing rockets now.
Yep.
Do you think it will be a day we'll...
Military space.
Yes. Do you think it will become a day where we 3D print Iron Man suit and make humans better?
I think so. I think we're getting... I think we're getting to a point of where we're printing with completely different materials and stuff like that. If you start printing, this is going to sound absolutely insane, in a world of carbon fiber nylon that does have a malleability to it. If you're using Kevlar infused, carbon fiber nylon, and you print that in such a thickness, at that point, as long as the weave of that nylon and of that and of the Nomex and of the Kevlar is intertwined correctly, it's bulletproof, And so the thing is you can actually print replaceable plates for people, make them lighter, for the flak jackets and stuff like that. I'll tell you one thing: carrying a flak like that is heavy as hell. I'm just gonna put it out there. Helmets, for example. If you can 3D print a helmet that makes sense, that's bulletproof. That's NIJ level 3 rated. For 9mm and SPAL, or even just SPAL related, shrapnel, then you're onto something. And I think that, seeing that, people printing a form-fitting, exoskeleton to help people pick up stuff and carry stuff, as long as, it's a little bit, and that's where you get the mix of this robotic and stuff like that, to carry, heavier loads, help the artillery guy, carry the artillery shells back and forth, that are a little bit heavier than most. Same thing with the tank loaders, loading the tank ammo, the ammunition guys that we got out there in the fleets. The guys who are the ammunition techs out there are the ones that are taking the back break. Let them do it,
So just to follow up, just give you a little bit more to go with. So, we're using railgun technology. It's still in its infancy, and we're getting to the point. Maybe we could 3D print these projectiles that still have the all the properties of a mortar, but without the properties of the weight of a mortar or a rocket or whatever we're using as a projectile.
Oh yeah, if you can print titanium, you got a titanium based penetrator, tungsten. I'm not really sure. You start talking about sintering technology. The 3D printers and stuff like that, you can start printing some of that stuff.
Yeah.
Mm-hmm. The thing is that also gives the combatant commands the ability to also 3D print their training material, their training ammo, like their M203s. You don't really get to shoot a whole lot of M203s, in the Marine Corps or in the military for that matter, unless you're a grenadier, or unless you're in a unit that does have a surplus of them, where you can actually shoot the chalk rounds, pretty much a big giant round stuffed with chalk. But those things are still expensive. If you can 3D print the top of that, so when they come apart, you put it back together again and send it on its way, refill it and kick it back out. Or the HE rounds. HE rounds are very expensive. But if you can 3D print something that's got the weight and the mass of an HE round, you can get the gunners used to shooting that type of stuff. Yeah. It's using it, and also the replacement parts in the motor pool. We're using equipment that's on average, older than most of us. That's some of the newer, land-based equipment. You start dealing with the Air Force guys, and those guys have got B-17s that are freaking older than most of their grandfathers. Yeah. However, they need to have their parts to stay airworthy. Yeah. To keep those birds in the air and keep them to the best of their ability, you got to 3D print them. You got to 3D print the parts. Or 3D print the parts and send them off to go get CNC'd. If you can't 3D print the metal right there on site.
Right.
Yeah, I think I read the other day it was exactly someone got a medal for reverse engineering and 3D printing, kind of like a lost PLA casting type style model or a part for.
And that's a real cost effective way.
Yes, I can't tool that part anymore. I can't make that or machine that part, but I need that, or this entire jet is going to, or plane or whatever is going to be scrapped. You save millions of dollars, even though it's a little bit older. I bet you that part shows you that you can now start printing other parts.
Think about this. Think about, when you talk about robots, drones, 3D printing and stuff like that, kind of the same realm, is you start getting into new career fields. You start opening the doors for new career fields. You start talking about 3D printing engineers, freaking, metallurgists, or better positions for the metallurgists, for additive manufacturing engineers.
Yeah.
And the thing is, you take an additive manufacturing engineer, you throw them together with a robot engineer, and you got relativity space. They spit out a rocket with a with a kook arm and a spool of wire. And next thing you know it, you got a baby rocket.
I mean, and then the other thing to think of, and like I said, I'll pose another question to Champ, is okay. We all agree that 3D printing is a tool that everybody welcomes, although this is not new. This technology has been around before. It's more accessible than it has been before. But
more mainstream.
Could you imagine, if you will, if we were able to send 3D printing technology to, say, Mars, and then you were able to take that 3D technology and to build infrastructure on Mars?
Yeah, I think that's actually probably the best route to go. So if we're not already doing that, I think you should probably get on that, NASA, because that's what we should be doing.
Relativity space.
Yeah, relativity space.
They want to launch their...
Yeah, send the Stargate out into space. So first off, I want to kind of touch on Nick's question, because I wasn't thinking like an Iron Man suit in defense. I was like, your grandma with an Iron Man suit, like, has some road rage and a vendetta, and is coming after you.
The reason
she sure can't do bridge real well.
The reason I brought
old Granny doing bridge wearing freaking Iron Man suit.
The reason I brought up Iron Man, when we say make better humans, so I'm not a proponent of, hey, let's build this for destruction. Yeah. The defense is necessary for every country. Every country has to defend their borders. But when I start saying make it better humans mean I can make exoskeleton where a person can withstand pressures in the depths of the ocean. I can make a exosuit that a person can withstand the vacuum of space. Or I can use that for that person to be able to lift heavy objects or whatever it may be. Yeah. And the reason
like that exists already.
It came to mind, it's because a guy 3D printed a cosplay costume totally for an Iron Man suit.
And it's like, that type of stuff you're talking, also the exoskeleton stuff, is you can help people who are who are paralyzed from the waist down walk again.
Yeah, that too.
Get them out there walking again, or at least, be vertical for certain things. We've seen that come up a little bit here and there, with some of the stuff. Some of the stuff is actually pretty cool. But
it's all pretty incredible.
Honda back it's been 5-7 years ago. They made basically it was an exoskeleton where a person wore it on a lower body, and when they were doing work in like assembly, it would put them in a position, ergonomic every time. And they had people actually using these implants in Japan.
Yeah, no,
I've seen
that to me that sounds like it should be something already. To be fair, but I do want to get back to the question that you asked earlier about the infrastructure. I think that what you were saying, Nick, Relativity Space wants to shoot out a printer. They're already printing their rockets and their engines, which is incredible. And of course, NASA, the space station, has a printer on board. So I would assume that the lunar, station, whenever it gets built, is something similar, as well as onto Mars, which of course it should be the goal is to get out there.
I believe a $33 billion contract was offered to a company to build infrastructure on the moon.
Yeah.
I don't know what the contents of that contract state. I just know that I saw it the other day that $33 billion was sent to this company to investigate and work on and prototype how to build infrastructure.
Because you go back to it, you think about the developing countries and the developed. Like, what is a big thing that kind of sticks out? And it is the infrastructure. How do we get resources? We talked about supply chain and those things, logistics. But this just goes hand in hand with that. And then, like, if you're able to get infrastructure onto the moon, I am very much so thinking there's not going to be like a half dozen of like construction workers just going ham on the moon building this thing. No, I'm assuming it's going to be a lot of drones and a lot of or mostly drones, to be honest with you, probably, because they're not going to send a couple dozen. What, astronauts going to build it? No, probably not.
Well, here's the second part of that question. So what are the challenges? I can think of a few right off the top of my head, and then I'll let you two guys, the challenges of not building in space, but what are the challenges of making robotics and drones and these type of machines we need to do these things for us exploration of space. I think one of the biggest challenges is they still are dependent on humans.
Yeah.
So AI is not mature enough. The machine learning is there, the deep learning is there, the data analytics is there, but the AI still, it's a little bit quirky. It's a little bit quirky. And sometimes it could be very unpredictable.
Yeah, no, it tends to freak out a little bit.
But for me, that's one of the things I see.
Yeah. Now, it's like that I go to the point of where, you're dealing with finite dust. You're dealing with maintenance issues. At that point, until you can make something that is, impervious to its surroundings.
Maybe you could hermetically seal.
Possibly, but I don't know about you start dealing with like joints and stuff like that, though.
Well, not the joints. I mean, like you can hermetically seal, but with the joints, you can make the joints. You can mill or machine fine enough that it would be harder, and then you can pressurize inside.
Yeah,
so
it blows out.
That would be something that you could do, but I don't know.
Yeah, you start dealing with like brushless and brushes and stuff like that. It's just you start dealing with that finite powder, that moon-based powder. If you've ever seen it in person, at Kennedy or something like that, and you see it sitting there, that's just thinner than chalk dust.
Yeah.
It's like how do you build I understand how you build
something to stay.
Like we build the rovers now.
Yeah.
The guys are really great. I mean, JPL, the guys at JPL, NASA's JPL are great. The stuff they've done with Curiosity, the stuff they've done with all these other rovers, that have been on Mars for decades at this point, and the ones that we've had sitting on the moon.
Yeah.
They know how to build them. Yeah. But the thing is the least amount of mechanical parts possible.
Yeah.
And it's all dry sump. No lubrication, processes, and mostly built off of air.
Yeah.
But the thing is, if you think about it, if you start dealing with like construction robots, you're dealing with robots that have to weld. You're dealing with robots that have to stack. You're dealing with stuff that's going to have some dynamics attached to it. And the big thing is if you're dealing with a robot that has to weld of any sort, how are you getting an arc?
Yeah.
And when there's no oxygen.
In a vacuum. That's what I was about to say. Like,
but here's the thing: we said 3D printing.
Yes.
So the key is the 3D printing has to be at a mature enough level that we can now make some of these alloys, with the 3D printing process.
Mm-hmm.
So it's no need to have an arc or a welding robot because I'm assuming it need to be modular. Yeah. Whatever we build needs to be like, it need to fit together like Lego blocks. Mm-hmm. And then I'll throw this at Champ, and I know we're getting a little long. Well, what do you think about energy source? What are some solutions to the energy source?
So that's particularly difficult because the current reason we haven't gone further or done anything like that is there is a statistical, I guess, or mathematical, I guess, limit. The Newton's law of force equals mass times acceleration. If your mass is set, you can only accelerate to get to a certain point to get that force. It can't reach infinity. It won't. Law of the conservation of mass will not let it. Mm-hmm. So in that sense, it's going to take so long to get anywhere, and thus to create the energy to move us that distance, we're draining the mass away, like the fuel that is on the ship. So the current problem is the mass to fuel ratio of a rocket. Right now, that's because we're doing certain types of chemical reactions, right? And if you get into like you talk about if you just have a fire and a fire's steam is moving a turbine, that's energy. You get into a little bit more or greater energy and nuclear energy, right? And that's very similar process. I mean, it's involving nuclear fission. But nowadays, the biggest thing that scientists are working on is nuclear fusion. And nuclear fusion that's what the sun is doing to create helium, and that is, I'm not even sure the number, but it's substantially more than fission creates energy. So for me, if we're trying to do some type of energy or trying to get somewhere, the first problem to solve is how do we get those resources there? And nuclear fusion is going to have to be the way that we get it long distances in shorter amounts of time. And then going forward, so we have, let's say we only have one reactor and it's on the spaceship. So how do we create it when we're on the ground? In that sense, your 3D printers have to step back in, and I'm assuming some type of, right now, solar would probably be a best bet. I'm not sure in a lot of places I don't think there's a lot of wind on Mars, to be honest with you. No. There might be some sandstorms, a little bit, but like in my mind, water. If you set up a wind turbine and it's a sandstorm, you're causing damage. I would much rather have some type of solar panel that's charging a capacitor battery or some sort that I could cover up. Now you could always cover up your fans, but in order to get the best, stream, it has to be higher up. So you can't really do it.
Well, if you think about it, if we want to get on this rabbit hole a little bit,
I could talk forever on this.
If you think about it, Curiosity found out that Mars is made 95% mostly made of CO2, and is able to convert that CO2 to oxygen. If you're able to take that CO2, convert it to oxygen, you can turn it to a power source. If you take it, what does oxygen turn into? Water. What is water?
Yeah, bring hydrogen. Oh, no, yeah.
You got hydrogen. Yeah. Now you got a power source to power the 3D printers.
And you can use fuel cells.
Exactly. Yeah. You start dealing in that realm.
Well, yeah, of course.
Hydroelectric power.
I was gonna say hydroelectric as well as we have hydrogen fuel cells as well too. So.
Yeah. So it wouldn't be me if I didn't give a curveball. So here's the curveball. Oh, so I heard you say fusion, fission. I heard you say solar power. I heard you say wind.
Yeah.
And power city.
Chemical reactions. I heard that.
Yeah.
So you both are familiar with a rail gun, right?
Yeah.
Nothing but magnets.
Why couldn't we make a rocket a rail gun? There's magnetic fields in space.
Oh no. You absolutely can. Will you survive the inside? No.
Yeah, you'd be liquefied by that point.
If I don't need humans.
Oh, okay.
And the rocket is a drone.
That's fair. no.
If you're doing like point-to-point transport, you just got to make sure you got something that can withstand the G's.
I think my biggest question would be with that is if that magnetic field, because it's got to be strong, if that magnetic field incidentally creates some type of electronic field, because they propagate off of each other. I worry about the electronics on the rocket, but
not necessarily, because like EMP bombs, the way that they do to protect it, they make shielding around the electronics. So what happens is the pulse goes around the box. So as long as you shield the electronics, the pulses will go around the box.
I mean, if you're creating a Faraday cage or something like that, but only the outside of it is
right.
Magnetic to be able to be projected at that speed, I think it's possible.
I'd be afraid of what happens when it lands.
So
that's true.
You don't have to worry about the landing, because
I got a parachute on there.
No, not even that.
It's got a blanket.
If I can control if I can control the magnetic field.
Yeah.
So the reason I say it is because, like I said, I was gonna throw the curveball. You know, it's gonna be some people like, what? You know, Nikola Tesla figured out the resonant frequency of Earth. Why couldn't somebody figure out the resonant frequency of the universe? Harness that energy.
Yeah, that's a big equation.
I know.
Have fun, champ.
That's a big equation.
But computers are getting more powerful.
No, they are, and you're not wrong, because they did, like, this is something that we could probably talk about on another one, but physicists actually put the mathematics in for the Einstein-Rosen wormhole and have kind of created it in quantum computing. So
we're getting stuck in a whole lot of lost in space stuff here.
Yeah, I'm just saying, that's terrifying.
10 years from now, we'll be saying, oh my God, why do I need a laptop? Because your watch will be able to do everything you want it to do, and most of it will be by either it knows you, or it'll be by, hey, I don't want to write the stupid paper, write it for me.
Oh, that's already around, because they're doing that.
But
now.
I mean, it'll become
dictation.
Yeah.
Humans have to become more accepting of it. It has to become more everyday. It has to become a part of life. Like how tablets pretty much got rid of. Well, I don't say get rid of, but tablets kind of help people steer away from laptops.
Yeah.
Laptops help people steer away from desktops.
Stuff like that.
Yeah. Smartwatches help people say in the phone, well, I don't need the laptop or the tablet. I got a phone and I got a smartwatch.
Yeah.
I at that point, we can go on this for days, and we're getting a little long, but not as long as usual, which is pretty good. But with that, here's an idea. Okay, if everybody if whoever listens, see how many people does it, goes to this video on our YouTube page, and I don't know, let's say if you comment 0G, or vacuum for that matter, we will figure out a way to test a mini 3D printer inside of a vacuum chamber on the YouTube channel for you.
That'd be pretty cool.
Just to see what happens. So, but that's only if we get people that are going there and freaking putting that comment on there, so we can kind of see what's going on. Let's see if they want to do it. We may still do it anyways, but for now we're going to give y'all the ability to dictate, how fast that shows up.
We'll do it anyways, but keep it to ourselves if you don't.
Right, exactly. And I want to say, thank you. We finally hit the magical 1,000 all-time downloads just the other day. Never could have thought that we would hit 1,000 all-time downloads. Never really thought that there'd ever be 1,000 people out there that want to hear me run my mouth, But I do want to say thank you to every single one of you, who listen, who share this with your friends. Go out, subscribe to our YouTube channel. Share some of the videos. Get people out there. Go take a look at the blog. It's doing a real good job on that. At blog.vulcanara.com. Go take a look at all that. And we thank you. I'll turn it over to the guys for the closing remarks. Y'all have a good one.
Like I said, I'd like to echo what Nick said. We appreciate everybody listening, supporting us. Like I said, when we started this, it was, hey, let's do a podcast, and it's like, okay, why not? Because we like talking about technology. We're passionate about this type of stuff. We're probably not the smartest guys, but we're probably one of the most passionate group of guys that you'll meet when it comes to talking about technology. So I'll just like appreciate everybody supporting us.
Yeah, I mean, the same thing for me. Like, I don't think that if these guys didn't stop us, I don't think I would have stopped. Because there's so much more whenever you start kind of opening that Pandora's box, or that going down that rabbit hole of why versus why not, how versus how it's made. I know everybody remembers that show, How It's Made. I used to
Ding 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 ding.
used to watch it every single day, 3 or 4 episodes, just because I was.
Yeah.
It was beautiful to see a process. So to be honest with you guys, I kind of want to do the thing anyways.
Yeah.
But I don't know if we should if nobody comments. So I'm gonna kind of stick on that piece.
So I always have to like give Champ something. I feel like
Yeah.
I always have to.
Champ's homework.
Yeah. Have you seen any of the like Mr. Wizard?
No.
You haven't seen Mr. Wizard?
No, I haven't seen Mr. Wizard.
The professor that did the experiments.
So I gotta look him up then.
Look him up, man.
Yeah, I'm gonna look him up. I'm gonna look because I love Neil deGrasse Tyson.
Yeah,
I love Michio Kaku.
Well, this guy was way before those guys. Like this guy, he did like experiments.
Remember, we still need to make him watch Down Periscope.
Yeah, I gotta watch that movie too. But anyways, guys, we digress. So we appreciate it. Like it's always nice to see that number. Happy 1,000. Thanks again. Comment on the YouTube page. Don't forget that. And we'll see you next time.
Yeah, and there could be a giveaway coming soon. So.
Oh yeah.
Y'all stay tuned. All right. Bye. Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.